Good day, everyone, and welcome to today's StarWind webcast. This presentation is being recorded. Now for opening remarks and introductions, I'll turn the conference over to Chris Flack. Chris, please go ahead.
Hey, thank you so much, and welcome everybody in our audience to today's webcast, Microsoft Windows Server 2012 R2, Deduplication, Backup, and Primary VM Storage, sponsored by StarWind. I'm Chris Flack with Redmond Magazine, and I'm going to be your host for today's event, so thank you all for joining me. Highly appreciate it. Just a few quick things before we get started with today's presentation and introduce our speakers. Just a few quick reminders that we will have a Q&A at the end of today's presentation. However, we do encourage you during any portion of today's presentation, if you have a question for one of our presenters, please feel free to enter it at any time during the presentation. And hopefully, if time permits, we'll get to everybody's questions and get out some answers at the end of today's presentation. Also, today's webcast is being recorded and archived for future viewing and listening purposes, and we'll send you a link to the email you registered with within 24 to 48 hours after today's presentation. Joining us for today's presentation, we have two really great presenters. Later on, you're going to hear from Ryan Post. He is a systems engineer at Veeam Software. He's been a systems engineer for over 2.5 years, and he's worked and got extensive knowledge in the IT industry for numerous years beyond that. Also joining us for today's presentation, and first up today, is Max Kolomyeytsev. He is a product manager at StarWind Software, and he has 7 years of QA and tech support experience at StarWind, 10-plus years of IT experience, and he's the host of StarWind's technical webinar series, just like this one. Briefly, just to go over today's agenda for the webcast, you'll have a little brief overview of Windows Server 2012 Dedupe. We'll talk about some Veeam backup and replication with Ryan. We'll get some StarWind information from Max later on in the presentation as well. And then we'll have a wrap-up and Q&A where you could ask both the guys what they think and what some questions that you may have. And with that, I'm going to hand everything over to Max so he can get started. So, Max, why don't you take the floor?
Yep, Brian, thank you. Chris, thank you. And hello, welcome on our today's webinar. Thanks for joining us. So there will be 3 deduplications we'll be discussing today, although the actual deduplication is just one term. Let me push the first slide to our audience. And first deduplication solution we're going to talk about is Microsoft Windows 2012 deduplication. So Microsoft has presented a very handy tool for their 2012 operating system. So now, as soon as you install the operating system, you can enable deduplication for your primary storage, and it will make sure your redundant data doesn't occupy too much space and help you save your storage and use it effectively. Now, it is available on per volume basis, so you can configure your storage to keep the data which deduplicates better altogether, like let's say user folders and other virtual machine data, which is really cool. You can configure everything from one place, and it also features PowerShell management, which also helps you to automate it if you're doing a bigger deployment. I'm not sure we're getting the full picture here, so I'm not sure. Chris, are we getting the full slide pushed to the audience? Just wanted to make sure we're getting the complete picture.
Yeah, definitely. I see everything going up here.
Okay. Yeah, sorry, it was just not showing part of the slide on my end, so I wanted to make sure we're seeing the full one.
Yeah. No, we definitely are.
Okay. So the next good thing about Microsoft's deduplication is its ability to use a variable deduplication block size that makes it possible to deduplicate different types of data more effectively while also preserving the system resources, because deduplicating smaller chunks obviously consumes more system resources. I know that Microsoft have used a special research for that and developed a thing called Raven algorithms to make the deduplication more effective, and their researches show that indeed it does work very well, but let's actually look how it works. So on this pictures, we see the basic principle and a bit more detailed technical principle of Microsoft Windows 2012 deduplication. So the upper diagram shows two different files having some similar chunks of data, different in size, and that's where their variable block comes in. And what Microsoft does, once this information is written, after that it jumps in and figures out that A, B, and C are actually similar in these files. So at a certain point, they just store in a chunk store, and when user tries to access the actual files, it accesses the metadata, which then points it to the single instance where the actual data blocks are located. Now, this process is not live, so after you write the data, it takes a while, make sure you're finished writing, and only after that, it jumps in and starts optimizing it for you. There are even 3 types of jobs you can schedule for deduplication, which is optimization, compression, and garbage collection. So you can really fine-tune what you get from this solution. The basic view for the user will look like writing the data to the array, and then offline data reduction engine processes that data and writes the optimized data back to the storage array, like it's pictured on the image below. And we have Ryan from Veeam here, and Ryan is really experienced in using their deduplication tools as well as Veeam's own deduplication. So Ryan, would you tell us some use case scenarios which you see for Windows 2012 deduplication in your case?
Yeah, definitely, Max. And what we have, as far as the Server 2012 case is as a backup repository. Given the fact that we already do a little bit of dedupe compression ourselves, which we'll talk about here a little bit shortly, is that with its dedupe area, it's going to take a lot more of our files and dedupe them across, right? So storing that data for longer periods of time, getting the archiving that you may need versus everything to raw disk. So really, again, implementing really what Server 2012 has already given you in the workings, right? Enabling that deduplication without having that specified device for that.
Right. So basically, you're getting your files deduplicated from the hypervisor to your backup, and then Microsoft optimizes the entire backup repository to make it even smaller than it was before.
Exactly. That's correct.
Right. Yeah. And we'll also talk about some use cases of deduplication for primary storage. Like a lot of blog posts have described that Microsoft deduplication is versatile. You can tune it for different tasks, but mostly people tend to use it for user data, which is not changing frequently, because otherwise some people reported they wanted to get more performance and they wanted to get Microsoft deduplication to be more effective. So there are some scenarios where you can use it, and there are some scenarios where using it won't make much sense, like live virtual machine data on old flash arrays. So in this case, for example, Microsoft deduplication may produce additional overhead with post-processing, which you don't want. So in this case, you can be covered from a different side. But those are some technical details I don't really want to disclose right now, because we have Ryan's part. Will he tell us about Veeam deduplication and what's the magic happening behind the scenes in Veeam?
Thanks again, Max. Yeah, so there might be a lot of people on this webinar that may be new to Veeam. Right, so I kind of want to give a quick introduction to what Veeam brings to the table as far as a backup or replication solution And then we'll jump into the specifics of our dedupe, how it can be used in relation with Server 2012 deduplication, but also other deduplication technologies. But kind of starting off, Veeam is a purpose-built solution, right? We focus on virtualization. That's why we have great new features coming out each and every release. Whether or not it's a groundbreaking feature, changing virtualization backup, or it's a customer-requested feature to keep our customers happy, right? But one of the biggest things that you'll actually see, as a big difference between us and especially legacy solutions, is that we are completely agentless, right? You're not having to purchase, deploy, manage agents in order to back up or replicate the virtual machines. That leads us to leveraging the APIs available to us from the hypervisors. So the two hypervisors we support is Hyper-V as well as VMware, leveraging their APIs for snapshots. Take a guest OS, the virtual hardware, all the objects associated with those VMs wrapped up at that image level. Right? And then lastly, we have our built-in deduplication compression, right? The ability here to achieve those smaller backup files, save on disk space, and keep more store points for the long run. A little bit about the architecture of Veeam, right? Or a little bit more about it. It does provide backup and replication. Backups, we are targeting disk storage, right? Creating those deduped and compressed files, where we also have replication. That's going to be a little bit more of your disaster recovery capabilities of taking a virtual machine, replicating it from one host, whether it's on-site for high availability, but most cases used for that disaster recovery going off-site. Deduplication compression is actually used during replication as well to help with that transmission from site A to site B and vice versa. Right. So we have a lot of restore capabilities, which I'll briefly touch on here, before we really start talking about the deduplication. We have everything from quick restores, instant VM recovery, where we can actually have the backup file actually run as a production VM. We have everything from the file level capability going into back into production, even VM files like the VMDK, VMX, VHD, going into a data store, the storage that you select. But we also have applications in regards to Active Directory, SQL, Exchange, SharePoint, really any other application we're able to restore from as well. So, but really about the architecture of Veeam, it is a distributed architecture. So we are going to have three main components. The Veeam server itself. So this is where Veeam is installed, responsible for the administration, the load balancing within the environment. It does require a 64-bit OS of Windows. And you can have this as a virtual machine or a physical machine. It really does not matter to us. Right? The second piece of the architecture you see here is the backup proxy. And this is the heavy lifter of our architecture. It's gathering the data, and that's the component that's responsible for our deduplication and our compression and getting that information to that third piece of the architecture there, the repository server. So in the Veeam world of things, we are able to back up to any disk type storage, right? Whether it be a NAS device, a physical server with local direct attached storage, a SAN, or in the case of today's topic, a dedupe appliance, right? And specifically with Server 2012 and the technology it brings to the table. Right. Now, from the point of Veeam deduplication, we are performing an inline deduplication on a per job run, per job basis. So as you can see here with the block level that we're performing at, any virtual machines that have a similar block structure is where we're going to get that dedupe. So, take for example, you have 10 Server 2012 virtual machines. Right. Well, all those system files are really going to be backed up once, and then with our dedupe, because of the block structure, everything's going to be pointing to that first set of blocks that was actually backed up. So we're not having to sit there and have 10 sets of system files. right? So same thing, for best practices for Veeam deduplication is having VMs built off the same template, having the same OS, really to get the best deduplication results, right? Not to say that you can't take a Linux server if you just have one Linux VM and put it in the same job as a Windows server. There's really just not going to be much dedupe from that point with that. But again, they can all still be contained within one backup file, right? So when we actually take a look at the settings for the deduplication, we have a couple different block sizes, that can definitely achieve, better performance, within, the type of storage that use the block size maybe within that Windows Server 2012. But the couple things that we have here, we have a local target 16 terabytes plus. I personally haven't seen anybody get to a backup file that size yet, but it is a 8 megabyte block size. Right? The next local target is a 1 megabyte block size. That is actually the default value if you're to just create a Veeam backup job from scratch. As you start going maybe for other certain cases of maybe going to a NAS device or going off-site, the LAN and WAN target approaches give you a little bit smaller block size, with the LAN target being a 512 KB block size, the WAN target being a 256 KB block size. Now, the WAN target is a great option for replication. Now, I know we talked a lot about backups, but replication, again, going from site A to site B over a WAN, that's really where you get that best performance during that process. Right? So again, our dedupe resides in both our backups and replication, but for replication, just from communication from site to site. So a little bit about how we can fit in with that Server 2012 dedupe. Right? So before that, why choose a dedupe appliance or Server 2012 dedupe? As mentioned, these are our backup files in a forward incremental backup structure. We also have a reverse incremental, but for best practices going to dedupe devices, we recommend this forward incremental approach. So you see .vbk files out here. There's two of them. They are full backups, right? They're everything that's within the virtual machine. Those full backups can be restored without any other files, right? They are standalone backup files. The .vibs are just incremental backups from the change data from the previous job run. So one thing that we leverage, we have the built-in change block tracking from VMware that we leverage to figure out what's changed from the previous job run and just back that up. With a Hyper-V infrastructure, we've actually implemented our own change block tracking engine. It's certified by Microsoft as a component that is fully working with their software, with Hyper-V. So we back up just the changes to .vib files. So with Veeam, if we took this as a weekly starting with Sunday with that first full backup, that next full backup be the next Sunday, each one of these files is only deduped with itself. Right? So that's the per job run, per job basis deduplication. Now, with a dedupe appliance or Server 2012 duplication, it will then take all of these files and dedupe them with each other. So again, you get the additional savings with the dedupe of another third party on top of what we've already performed. But there's also, within Server 2012, just kind of a screenshot, Max has already hit on it, that is a per volume, right? It's just the role that you're going to go in and associate that Server 2012 R2 server. And then we have the file age, right? The file age is basically a landing zone. So there's going to be a certain time frame for a file for the age that it's going to actually stay hydrated before it gets moved into that dedupe partition within the volume that was selected to have deduplication. So what's great about that is leveraging it for Veeam restores. Right? We have a lot of great restores that are out there. One is instant Veeam recovery. Right? We talked about that briefly. We're able to take a backup and run it directly from the deduped and compressed state. And a lot of times there's other dedupe appliances out there that doesn't have this sort of hydrated landing zone or hydrated state of the file. So we have to do that from a deduped file that's already been deduped by that appliance. So the performance there is going to be a little bit worse. Whereas in Server 2012, that hydrated file we directly have to restore from is going to be able to give us that best performance with an instant Veeam recovery. But it's also better for anything with that file age. It can be set on a day. I believe the default value, if I'm not mistaken, is 4. You could definitely set that higher or lower based on your needs. Do you usually go back more than, say, 4 days, for a file? Maybe change that to 7. And then there's a lot of control mechanisms, that take place, and I believe Max is going to go into them, such as the garbage and the scrubbing that you may be able to clean up between that volume. But of course, there's always going to be some best practice considerations as well that you want to follow when talking about using Veeam with a Dedupe appliance. One's compression. As you can see there with the screenshot from a backup job within Veeam, there is actually a Dedupe-friendly option. The reason why we have that there is, well, we want to give the Dedupe from the third-party Windows Server 2012 more to work with. If we actually put our high compression, which or high or extreme, which can be upwards around 10:1, that's less data that the Dedupe appliance or Dedupe software is going to be able to take and get out of, right? So it's not going to be able to give you what they've promised for deduplication. Also consider the amount of data, right? Within Server 2012, there are some things where it's just about 100 gigabytes per hour, about 2 terabytes per day that it's actually able to process, through its deduplication settings. So if you have a little bit more data than that, you may want to consider, multiple backup repositories that enable the dedupe, or maybe pick and choose, different virtual machines, maybe into a particular Veeam job that's going to go to that dedupe appliance, maybe the ones that you need that longer attention for. And just to mention, within Veeam, you can have multiple repositories, right? You could have certain types. You could have as many as you'd like, really, to really help scale out within your architecture. And then lastly, throughput. With Veeam, it's important to be able to write to a backup repository, to achieve optimal performance. Some of the other components that I talked about, the proxy servers, the heavy lifters that help us scale out, it all comes down into one repository. You got to be able to make sure it handles that throughput. Types of disks, the type of network cards, what is it communicating with, all play into that throughput that we can achieve. Now, there's also one other consideration that I thought of as we kind of started this presentation today is the use case of a Server 2012 virtual machine with Dedupe on for, say, a file server. Veeam, we fully support backing that up. Right, we can back up those VMs on that have a Dedupe virtual disk. However, one consideration I want you to think about is restoring from that. And as a best practice, and to be able to restore, it would require that Veeam be installed on a Server 2012 virtual machine. And we also would want to have that deduplication turned on just on that Veeam server. So when we access, say, a VMDK or a VHD that within Windows have the Dedupe turned on, we can actually go in, explore those files, and restore them back for you into production. So, and that's really kind of a nice overview there of how Veeam is going to provide the capabilities to back up to Server 2012 and some of the considerations there for that. So with that, let me pass it back over to Max, and he can continue on with a little bit more with the StarWind capabilities.
Yeah, right, definitely. Thanks for a great overview of Veeam's deduplication. And now we know how to deduplicate the backups, but in order to have the backups, you have some production data you value and which you would like to back up and deduplicate. And here is where StarWind comes in. So a part of Microsoft deduplication, StarWind is primarily oriented on live VM data. So a brief overview of StarWind. I'm not sure if all in these webinars are familiar with what we do and what StarWind Virtual SAN is. Well, it is a software, native Windows application, which allows users to create a virtual SAN using just the servers and their local storage, and thereby it has zero hardware footprint. Since it's a native Windows application, it's extremely easy to use. I'd say network administrator spends less than 30 minutes to set up the software, provide shared storage, and start provisioning highly available virtual machines in a clustered environment. And it is primarily designed for virtualized workloads. So we're not focusing on file server loads or backup loads. We do support it, and there are scenarios where we work with them and we accommodate them too, but primarily we want the live VM architecture to be highly available, effective, and easy to manage. So here is a basic solution architecture we have. As you see, there are two standard servers using common off-the-shelf NICs for synchronizing the data between the servers. And StarWind is installed either in the hypervisor as a virtual machine, or if it's Hyper-V, it runs as a native Windows application on the host OS level, so basically in kernel. And it takes local disks, mirrors them, and then presents it back to the system as a single shared storage resource, which on top of that is also fault tolerant now. So we synchronize the data, we synchronize our level 1 cache, which is RAM of these same servers, and we also synchronize the L2 cache, which is SSD. And once you have that running, you can start provisioning virtual machines on it, and here is where our VM-centric file system comes into the game. So let me push the next slide, and we'll discuss it with more detail. So first thing you would like to do if you're running virtual machines and any virtualized environment is to eliminate the IO blender. And here is where StarWind LSFS, which is log structured file system, comes into play. Basically, every random write stream is converted into a sequential write stream, and then instead of writing a lot of small blocks, StarWind writes all the data to the disk in big chunks to make sure the data hits the underlying RAID stripe and gets maximum performance from your underlying storage. Now, next thing for virtualized environments is after that data is written, the actual amount of data is shrinked, because at the level of level 1 cache and level 2 cache, there is an in-memory deduplication process which strikes out the redundant blocks on the fly and makes sure that only the dehydrated data hits the disk. This has two benefits. First one is to keep more data in the cache and make your storage solution closer to in-memory computing. Basically, when you access multiple virtual machines and their deduplicated data is kept in cache, the probability of hitting that block in cache is much higher than with a regular storage solution where the data is non-deduplicated. Another good thing about inline deduplication is that with the data constantly being changed, an offline deduplication engine may work, but your underlying storage will grow and shrink, and this is not something every storage solution can accommodate. And if we're talking about all flash arrays with a high cost of every byte we write, writing less data is good because we keep it smaller, and it's also good because we prolong the cell lifetime. So the cells don't burn that fast, and we get rid of so-called spot burns. And let's switch to the next slide. So as I said, inline deduplication compared to offline deduplication provides certain benefits for the flash storage. With having it deduplicated, we can also use our SSD caching more effectively. Let's say you have a standard spinning array behind the scenes, and then on the front end you have your RAM cache and you have your SSD cache. So once you've written that virtual machine data to your storage array, you have at least 60% of it in the SSD cache, and it is then retrieved from the SSD instead of going directly to the spinning disks, which increases the performance of the solution. The typical system requirements for Microsoft offline deduplication are 2 gigabytes of RAM per 1 terabyte of storage, and that's, as I mentioned earlier, Microsoft has a variable deduplication block size, so they preserve the system resources, but as they start deduplicating, it may get a little slower for primary VM storage because they're only using single-threaded process, which does not fully utilize your CPU and may not be sufficient for the data, which is constantly changing. So by the time the data got dehydrated, the amount of data which actually changed may be dramatic. So StarWind does everything inline, and it requires a little more RAM. It's 3.5 gigabytes of RAM per terabyte of stored data, and we do not use variable block size for the deduplication. We use 4 kilobyte block, which is slightly smaller than Microsoft has. Average deduplication block size in Microsoft deduplication is 64K, and StarWind uses 4 kilobytes. Now, both solutions are not CPU intensive, but StarWind distributes this load on all the threads in the system you have. There is also a way to configure it not to use all of them, but really with a modern CPUs, we've seen less than 10% of the CPU being utilized by StarWind, fully saturating a 10 gigabit link by writing a stream of data to the array and also deduplicating that data on the fly. So for a hyper-converged SAN, that is an excellent result. And at the end, I just wanted to show a quick picture showing the primary difference between two methods. Where on top, we see the offline deduplication process. This one is really good for file servers, offline user data, or any other information which can be changed and dehydrated overnight. And when users come in the morning, they have all the data deduplicated and optimized. But as you see, the data actually hits the array twice. And if we think that our primary intention is to use it for, let's say, live virtual machines, or we maintain a 24/7 production, this may be not the solution you're looking for, at least for some scenarios. So in this case, your live VM data can be deduplicated inline using StarWind's deduplication, like on the diagram below, where raw data hits the inline data reduction engine, which sits in the RAM of your server, and then once it's optimized, it's written to the storage array. And both solutions can coexist, so you can have your user folders deduplicated by Microsoft on the client side. You can also have them deduplicated on the actual virtual machine side. So it's the same thing as supported by Veeam Deduplication. And on the very back end, you can have the inline deduplication handling the primary VM data and making sure that your high-performance storage array only works for the active virtual machines and works with maximum efficiency instead of searching for every single block, even if it's 100 times redundant. So I think that's all for the StarWind deduplication description. And Ryan, would you help me with the takeaways for this event?
Definitely. So, one of the biggest things to keep in mind is storage requirements are reduced. Whether it's using it for that production environment, maybe particularly maybe the VDI employment, you're going to use less storage for those multiple VMs when the I/O requirements can handle that deduplication. But again, it can be used for production and target storage, deduplication. From the standpoint of what Max talked about, going in, as long as the IOPS can handle it, using it for production. Depending on each and every situation, it could be different. But from a Veeam standpoint, it's target storage, right? Using that to take Veeam backups, get more out of them, keeping more store points, giving you that long-term retention you need without spending that abundance on just raw storage. And then really keep in mind your environment. I've mentioned it a couple times here at the takeaways. IOPS is always a big concern from both the standpoint of production and target storage. But really do an evaluation of looking at all the components, and there's a lot more you could definitely go into than what was shared here today to see if deduplication is going to be the best fit. Right? But one of the kind of the great things is that there are resources from the Veeam side as well as the StarWind side, and Max probably can confirm that would be would love to discuss these situations with you to see what might be the right way to go.
Right. So there are a lot of scenarios we could discuss, but this could take hours for us, and every particular scenario is just so different. And Ryan's absolutely correct. The main thing is benchmark your IOPS before you go to production. Once you're in production, there is no way to take a step back and reconfigure anything, unless it's a fully redundant configuration, which is often not the case even in enterprise world. So keep that in mind, even if you're doing complete HA and you're rock solid with your SIM. One benchmark can save tons of hours over time.
All right. Well, excuse me. Thank you, guys. Much appreciated for your presentations, and thank you for spending some time with us today. We have a few questions here from people in the audience for some question and answer session. So please, at this time, if you have a question for Max or Ryan, please feel free to enter it via the Ask a Question box appearing on the left-hand side of your console, and we'll get to some questions and answers. So the first question we have running up today is, I'll direct it towards Max. This person's asking, we have 6 Windows 2008 file servers managing user data in 3 sites. They are all running DFS. Are there any issues or gotchas with implementing a 2012 server with Dedupe and adding that into an existing DFS environment?
That's an interesting one. So user data separated in 3 sites, and everything runs on DFS. So I would say that 2012 Dedupe implemented on every site may be sufficient, but I'm not sure at this point if DFS and Dedupe will work together to make it deduplicate across 3 sites. I'm sure it's viable for one site, but I would actually double check the 3-site deduplication in this question.
Somebody here is asking, can you use StarWind Dedupe inline with MS Dedupe, or can you not use both together?
You can use both Dedupes together. I'm just not sure the Microsoft Dedupe will have a lot of data to deduplicate after StarWind deduplicated it. I mean, you can use Windows deduplication on top of StarWind's Dedupe. That's possible. And we have at least 3 scenarios I took part in where 2 deduplications work together, either handling different types of data or one processing after the other. But in most cases, Windows deduplication was on top, deduplicating primary file shares. It was the scale-out file server. And then StarWind deduplication did the rest on the back end.
We've got a question here. I'll direct this one towards Ryan first, and Max, if you want to comment as well. Andre's asking, Ryan, how can I integrate Veeam Dedupe solution with a cloud storage service?
Definitely. So there's a lot of clouds out there: public clouds, private clouds, hybrid clouds. Ultimately, once we create a Veeam backup file, whether it's local, it's got to go to local storage first. It's going to be deduped to compress, and at that point, we can take that file and move it to a public cloud on the lines of Windows Azure or Amazon, Google, Rackspace. But you're also, to a private cloud, a service provider in your area. Really at that point, you've achieved a backup file that has a certain block size. So when it gets transferred, it's going to be comprised of those block sizes as it is transferred as a file. But we definitely have our own Veeam Backup and Replication Cloud Edition that will hook into the APIs of our public clouds that are out there. Again, the Amazons, the Windows Azure. But then there's also, again, VPN connections that you can make with service providers, pay for disk space, and use their private cloud. But again, they are stored, deduped and compressed.
I'll have another question for you here. This comes from somebody in the audience, Ryan. This person was asking you, does Veeam have the ability to quiesce SQL databases for both full and differential, and what about SharePoint and Exchange?
We sure do. So we actually do quiescence for any Microsoft application that uses VSS. Whether it's the ones mentioned, even newer versions of Oracle, other databases have VSS writers. So before we even leverage a snapshot from VMware or Hyper-V that we're going to leverage for the backup, we are going to quiesce those applications. As soon as that quiescence happens, we are going to take that backup, take that snapshot. Once that's created, we release that quiescence to the applications. Really very minimal impact. Users shouldn't even see a job running if you run it during the day during production hours. But yeah, we are going to make sure there is transactional consistency. We will also help with log truncation for successful backups by default for both SQL and Exchange. From a SQL standpoint, just kind of mentioned, if you have DBAs that are very nitpicky about their databases, you can definitely let them handle any log truncation, or if they're doing log shipping, all the quiescence and or the log truncation can be turned off.
I got a question. This one I'll direct towards Max. Can DFS be used for file server archival in a different location?
Yes. As far as Microsoft claims, DFS is supported with deduplication. So it interoperates, and basically optimizing a file will not trigger a replication, and this will actually keep the offsite archive cleaner and lessen the amount of network traffic between two locations.
Got a question. Oh, well, if you have a question, for those of you in the audience, we have a couple minutes left here. We'll get a couple more questions in before we close out today's presentation. So if you have a question, please feel free to enter it in the Ask a Question box on the left-hand side. Ryan, we got a question here for you. This person's asking, is it advised to use MS Dedupe with Veeam, or use Veeam's own compressing, or can they both be used together?
So they definitely can be used together. Again, coming back to that best practice of turning down the compression ratio that we're going to get out of Veeam. So it allows Microsoft Dedupe to get more out of the data when it goes to actually dedupe it. But then again, coming back to considerations and a takeaway from today, every environment's different. A lot of times it's just going to depend on the amount of retention you always need, or the amount of retention you're needing to keep. If you're looking to keep 2 weeks of data, you may be able to get that out of raw storage versus having to turn on dedupe. But if you're looking to get to months and months and maybe archive some full backups here and there, even leveraging a job we didn't talk about today, our backup copy job, then that's a great place for dedupe, and definitely making sure that the viable settings of the compression turned down is really something to look at. So.
We got a question here, direct this towards Max. Does StarWind have an independent dedupe index? And if so, how do you recommend backup and recovery of the dedupe index?
So StarWind's primary focus is high availability. So we do back up our dedupe index by ourselves by just replicating it between multiple hosts. So if you have one host, you can basically do a backup of the StarWind metadata files and map files from the volume which keeps the deduplication device, and this will do the deal. And you can also do a replica and just offload snapshots of your data which are deduplicated to another array. So this is another solution which can help in this case.
You got another question here for you. Max, this one. With this solution, will my main backup window shrink? Right now, we're up to 10 hours overnight and growing. Thanks.
Yeah, so with this solution, depending on the solution, with Microsoft Deduplication, the main backup window may not really shrink because it's offline processed. With inline deduplication, yes, it can shrink because it deduplicates the data in memory before it hits the disk. So it somehow unloads the underlying array, and as a result, you write less data, and writing less means writing faster.
I got a question here. Somebody's asking, what about orphan blocks? How will the solution treat them?
So StarWind treats orphan blocks by running a garbage collector and recomposing them. And some of these blocks will remain in the older snapshots. I'm not really sure how Microsoft Deduplication handles them. And this is something I'd like to search because that just had up my interest.
Question here for you. How much overhead does this add? Does it add much?
Well, the overheads, let's see. So if we're talking about Microsoft Deduplication, we may say that it adds some overhead to the disks because it triggers an additional write of dehydrated data to the array after the actual data is written. This is the overhead. With the RAM, as I said, 2 more gigabytes of RAM per terabyte of storage. And if you're using multiple volumes which you're deduplicating, in this case, let's think it will use more. I know there were some caveats and things which can be reconfigured but not visible by default, like deduplication only using 50% of RAM available to the server. So this may lower the overheads, but on the other hand, it may be something you're actually looking for to increase the deduplication performance. So that's the Microsoft deduplication overhead. I think Ryan can talk about Veeam's overheads added to deduplication. I'll just add that StarWind's deduplication has 2 to 3% CPU overhead, and as I mentioned earlier, requires 3.5 gigabytes of RAM per 1 terabyte of storage data.
Yeah, from a Veeam perspective, I mean, for our deduplication, it comes down to the proxy architecture. Of course, you can scale with multiple proxies, but when you look at one proxy itself, we're ultimately going to leverage with default settings, 1 core, 2 gigs of RAM. All right. If you want to get more compression out of it, we're going to recommend that you put the CPU higher. I did show you the one slide that had the different ratios. There was the extreme setting for compression, which wouldn't ultimately be leveraged if you're going to a dedupe storage. But that extreme would require at least 6 or more cores for help with processing. And then those different dedupe block sizes definitely comes back to the hash tables that we're going to need, and that is kept in RAM. So obviously the 2 gigs for the 1 megabyte block size, the local target, is what's recommended. But as you get smaller, a little bit more. Again, all kind of depends on the amount of data. Right? We recommend at the optimal or the default setting, 1 megabyte block size. We recommend a maximum of 8 terabytes within the job. I tend to recommend lower just for optimal performance. So.
All right. Well, thank you guys so much for your presentations today. You know what? We have one more question here. Sorry about that. This question comes from Tim. I'll direct it towards Max. It sounds like StarWind's big sequential write strategy has the same advantages as Nimble's CASL technology. Is that correct? Oh, hey, Max, you there?
Oh, sorry, I was muted. Tried not to breathe in the microphone. Sorry. Yeah, StarWind and StarWind LSFS and Nimble Castle technologies have some similarities, as well as they have some similarity with NetApp's Waffle. So it's the idea of writing everything sequentially and then keeping a separate catalog which will handle the reads. Because if you're compensating all writes to be sequential, the reads are inevitably be random and random only. So that's something we handle with our L2 caching. I know that Castle handles it pretty much the same, and as far as I remember, NetApp has a bit of different approach in this case. But yeah, these technologies help you to accelerate writes, and with modern virtualization in mind, it really works. It works great. It even allows you to use a RAID 5 in a production environment, which is something what people try to avoid for the last, I think, 5 years or even more now, when we started saying that, yes, with the type of array like this, you can still get good performance.
All right. Well, thank you, guys, and thank you so much for your presentations today, and thank you all for joining us in the audience. If we didn't get a chance to answer your question, we'll make sure to follow up with Max and Ryan and get your information to them so that way they can follow up with you. But thank you all for joining today's webcast, which has been sponsored by StarWind. And Max from StarWind and Ryan from Veeam, thank you guys for joining and participating today. Once again, thank you all in the audience for joining us for today's presentation, and we hope to talk to you again soon. Thanks for joining, and have a great day.
Good day, everyone, and welcome to today's StarWind webcast. This presentation is being recorded. Now, for opening remarks and introductions, I'll turn the conference over to Chris Flack. Chris, please go ahead.
Hey, thank you so much, and welcome everybody in our audience to today's webcast, Microsoft Windows Server 2012 R2, Deduplication, Backup, and Primary